I have provided a lot of information about drivers, hardware. So let's put all this information together and build a simple SoC. So in the beginning, we're going to restrict ourselves to a smaller system compared to this whole system that we're going to be building later. That smaller system contains the microcontroller here, or the processor. It will contain the bridge. And Mmio subsystem, it won't contain all the slots, it will only contain about 4 of them. So a timer, a UART, general purpose output connected to the LEDs, and a general purpose input connected to the switch. So let's go to Vivado and actually do this. And now we are in Vivado. We're going to start assembling and building the system. The first part we will do is actually the CPU in here, or the microcontroller units that is based on Microblaze. And the way we'll do it is actually by using the IP catalog. So we're going to go through the IP catalog. We're going to go to embedded processing, and within embedded processing you're going to see processors. So if you double click that, you're going to see Microblaze and a Microblaze microcontroller system. The Microblaze is a microprocessor. The Microblaze microcontroller system is a fully fledged microcontroller, so, and this is what we'll be using. You double click here, you'll get the wizard. So in this wizard you're gonna create a component name, and the component name is we're going to be using CPU because I'll be distributing other files as well that expect this particular name for that particular instance of the Microblaze. You're going to create instances out of it. The next thing you can change is you click on this tab, and this gives you the microcontroller system, so you can set what is the frequency of the clock you're going to be using. We're going to just keep it at 100 megahertz. The memory size inside that microcontroller, we're going to be choosing the largest, so we can place relatively larger programs. And then we're going to keep this as is, optimized for area, and then we're going to enable the I/O bus. So basically we're going to get some output out of the Microblaze that we will connect to the bridge, and that will be how we connect the I/Os. And then we're going to create OK. Well, before we do OK, you're going to see that there's an UART in here, general purpose output, general purpose input. None of them is checked. We can technically just generate it using this wizard, but what we'll be doing is we will write it from scratch, so you get to see the whole system being written in HDL. So we're going to do this here. We're going to click OK, and then I'm going to get a message that tells me like, hey, you need the synthesis option to be global, and then you leave it and you wait for a few seconds to get this done. And now that is done, you will see that I have in my sources, I have that CPU. If you double click on it or you try to expand it, it'll tell you that it's pretty large. We don't need to do that. What we can do is actually go to the IP sources in here, and within the IP sources, if you actually expand that, you can create the instantiate templates, and it will give you a VHDL version and a system Verilog, or actually a Verilog version, but because system Verilog is backward compatible, we're going to double click that. And what it really is doing, it's giving you the template that you can actually use to instantiate an instance of that particular CPU. So the module name is CPU, like you have seen before, like what we did with multiplexers and decoders and whatnot. It's just called CPU. Then you can create it and you can use whatever name you want, and then everything else is set for you. So you can just take it and put it in your HDL file. And now you're ready to use that CPU. Okay, so next what we will be doing is we'll be adding the next items in that particular small system. So you can see that I have created the microcontroller unit now. We're going to connect it to a bridge, and you do see here a few file names, and these are the file names we're going to be adding. So the first one, I'm providing all the code for you now because the purpose is just to show you the whole system working between hardware, drivers, and application. So we're gonna create, I'm gonna give you some file for the bridge. I will do the same thing for the Mmio subsystem in here. It's not the full Mmio subsystem, it's just a version of it. So I'm gonna give you one for the whole system in here, and inside it you're gonna have a file that actually is for the controller, a file for the timer, a file for the general purpose output, and a file for the general purpose input. The UART is a little bit on the special side. It has actually a bunch of files, and there's a little bit of a hierarchy because it also has FIFO. So let's get to it. So we're going to go in here, we're going to go click in there, and we're going to add actually the resources, and from the resources we're just going to add files. And now we double click on the HDL, and I'll add them one by one. I'll just explain what they are in here. So the first one we're going to be using is the bridge. So this is for the bridge, and then I want the Mmio system, and that's it. And then inside it there's the controller, and inside it there's the general purpose output, and inside it there's the general purpose input, and of course there's the timer. Okay, and of course we need to figure out these mapping of these modules where they're stored. We need that header file. This is the system Verilog header file. We're going to do this, and of course the whole system needs a top file that incorporate everything, basically the CPU and everything together. So we're going to create that. We're going to click this, and we're going to add it. We're going to add more files, and these files are for the UART, so these will go through these files, the meaning of what these files later in a different video. And then we're going to add this here, and as it turns out that the UART actually needs a FIFO, so we need the FIFO, basically the controller and the register file and whatnot. And then once you add all these files, you're going to see that it will create that hierarchy for you, and you get to see it. And that hierarchy should match exactly what you do see here on that particular graph in here. So let's take a look briefly here. So I have a top file, and the top file describes the whole system. So within that system, you're going to see a CPU. This is exactly what we did in here. We called it CPU. And we have a bridge, and that's basically this one in here. And of course, we have an Mmio unit or Mmio subsystem, which is the whole thing in here. So if you actually expand that, you'll see exactly that there's a controller, which is this point in here. You're going to see a timer connected to slot number 0. Slot number 1 has the UART, and the general purpose output is number 2, and the general purpose input is in number 3. And of course, within the UART, you're going to see some sort of a hierarchy that we're going to go through later, and inside it, there's actually FIFO buffers. Okay, so that's pretty much it in terms of the source files. You can actually read them on your own. You can see it. For example, you can see the top file. It's just basically an instantiation of whatever we talked about a few minutes ago. And you can also go through the interesting one, which is basically the Mmio system in here. You can see, I believe, if you do actually the controller, you get to see the different modules and where they're connected to, the different slots and whatnot. Okay, I think they're here actually. So you're going to see that slot 0 is the timer, this is the UART, and I'm basically instantiating an instance of it, and I'm connecting it there. We're going to go through more information about it, but I do recommend that you actually read these codes on your own. So the hardware level is almost complete. The only thing we need to add is actually a constraint file, because we will be actually uploading this code at some point to the board. So we need some sort of a constraint file. I think I created the source in here by mistake. I have to do the constraint. So you do the constraint, I add a file, and then we go in here, and I'm just gonna give you a special constraint file. It's actually already filled, and we will be using this even for the full bigger system, the one that has the video and everything. So if you actually go to the constraint in here, you're going to see that it's not only for the clocks, it's also for the switches. The buttons are already connected, the LEDs and everything else, because we're going to go through the rest of the course. We will be using these for some other things too. So now all we have to do is just basically generate the bit stream and wait for it to finish. Okay, so now that it's done, I can technically go to the Open Hardware Manager, and I can connect my FPGA and program it. Frankly speaking, nothing's going to happen on the FPGA. I'm just loading it with an empty processor that has no programs. So the actual steps in order for us to actually put and move into the next step is actually to export. We're going to go to File. We're going to go and say export not the bit file, but the hardware. So we're going to do that, and we're going to include the bit stream so we can actually program it. We're going to put the program and the bit stream together, and then this will actually create a file within that particular project here, and it's an XSA file. It just got created, and at this point I can technically just close Vivado, and that's it, and I'm done in terms of the hardware. Okay. So what we have seen already is actually the lower layer here is already done. Now I have designed my hardware, I implemented it in HDL, and I created the bit file, and it's ready to be placed on the FPGA, but it's empty. So what we need to do is we need to put some sort of a code on top of it.